further ado, let me introduce Gary Robinson, who's come all the way from California, beautiful Silicon Valley. Gary Robinson is a program director in IBM's Big Data organization, which also deals with Watson in California. During his 25 years with IBM in the UK and USA, Gary has worked on many emerging technologies in the information management arena, including decision support systems, multi-dimensional analysis technologies, data warehouse, information integration, RFID, and XML. His career has included roles in management, engineering, and marketing. He specializes in bringing new technologies to market, doing his best to reduce the fear, uncertainty, and doubt that often surround them. He holds 10 technical patents in relational, multidimensional, and RFID-related technologies. Prior to joining IBM, Gary worked in space research in the UK and semiconductor manufacturing research in the Netherlands. Please welcome Gary Robinson.
Thank you, Kai. And thank you, Amanda, and the organizer. I've sat through sessions all day, and I've had a great time. I certainly hope you have. I've learned a lot. And frankly, hats off to all of you for battling the weather, for staying right to the bitter end, but also for the work you're doing every day. I think you are raising the intelligence of the industries that you work in, helping us all make better decisions. Fantastic work. My hat off to you. Let me take you back to the beginning of the day when you heard Rebecca Costa talk about complexity. You heard her talk about how the world we live in has a tendency to grow ever more complex, and oftentimes that complexity reaches a point where we start to feel overwhelmed. We reach a point where we get gridlocked, where there are more bad choices than good choices, and we become paralyzed. And in order to keep things moving, we reach for decision-making tools that are not fact-based, are not evidence-based, but perhaps become belief-based. And then we start making irrational decisions, and we start driving things with irrational policy. And we've seen through history that multiple times this leads to collapse. I hope Rebecca will forgive me for condensing her whole presentation into one paragraph. The other theme today, of course, is business intelligence and big data. And so what I'd like to try and do for the next few minutes here is bring these two themes together. I'd like to suggest to you that this new generation of tools and technologies that we're seeing emerge right now can be just an amazing tool set to help us understand some of the complexities in this world that we live in and get our arms around some of the problems that we're dealing with and find a way forward. So hopefully by the time I'm done here, you'll be feeling a little more optimistic about where we're going than perhaps you were at the beginning of the day when we seem to be facing imminent collapse. As a Brit, I hope you'll forgive me if I suggest that if you want an example of gridlock, if you want an example of complexity and the problems we face today, you need to look no further than the American Congress, right? That's something that's very familiar to us all, and it impacts our lives today. But what I'd like to do is take a look at something a little smaller, a high failure rate environment. You heard Rebecca talk about high failure rate environments. The healthcare industry is a high failure rate environment. Let me talk through some of the problems that we're facing in healthcare very briefly, and then I'm going to show you some technologies that we're working on in that domain, and then we'll sort of peel the onion and look at what's going on underneath those solutions and why the pieces are coming together now. So, here's some very, very worrying statistics. Medicine has become too complex. Only 20% of the knowledge that clinicians are using today is evidence-based. So, you go to the doctor, you think this man, this woman, they're making decisions based on facts, on evidence, But here's an expert telling us that perhaps only 20% of the information that they're using is evidence-based. And these people are making life and death decisions, right? These are really, really important decisions. 20% of the diagnoses in the USA today are estimated to be inaccurate or incomplete. So there's a 20% chance that you go to the doctor, your diagnosis is going to be wrong or incomplete. These are scary statistics. 1.5 million errors every year in the USA in the way prescription medicines are written up or taken or dispensed. Huge numbers. And somewhere around about 100,000 people, 100,000 Americans are dying in hospitals every year as a result of preventable medical errors. So here's a perfect example of a high failure rate environment where those exponentiating wrong choices are having a compounding effect on us as human beings and our quality of life. This isn't happening because of want of information, right? There's a huge amount of information in the medical world. And in fact, medical information is doubling every 5 years. So if you set out now to get your medical degree, by the time you graduate, the amount of information out there will have doubled. Clearly, that's a problem. The Economist a little while ago did a survey and suggested that to keep up with the state of the art, a clinician, a doctor, would need to spend 160 hours a week perusing the literature. There are 168 hours in a week. So if your doctor's going to stay current, the doctor's got 8 hours to do everything else, including fixing us and eating and sleeping. So not a good recipe and not a sustainable model. We need to do something about this. So let me, I'm going to show you a couple of short videos. Let me start the first one up now. This is some doctors talking about Watson and Watson being used in healthcare.
What is Watson? It's data. We've been waiting for Watson for a long time.
Anyone who talks about Watson would describe it as being transformative.
When you go over to Watson, there's a whole new world.
When I look out at the healthcare delivery system, I literally see healthcare as a data problem.
It's not even possible for a physician to find the information that they need.
Things that aren't directly related to patient care take up more and more time during the day.
Proliferation of information is such that it's impossible to stay current.
Historically, we've never been able to know everything. And we can't even find everything now.
Unfortunately, we know what to do about 1% of the information, and that's perhaps a generous overestimate.
It's almost disabling to know that the answer to your patient's problem is out there, but you can't find it. Enter Watson. Watson has access to all the elements of the evidence pyramid.
Making sure each physician had access to all the information and all the knowledge, I think that will transform.
Watson can help physicians and patients improve care and improve health by drawing on an enormous array of information sources that no one individual can process all by themselves.
I think the holy grail for a system like Watson is, of course, going to be on the clinical end and ultimate decision support on that side.
That ability to have resources that are profoundly powerful to help you with difficult diagnostic dilemmas, I think are going to free up the docs to be able to spend more time on that whole element of a relationship, and doctors miss that. This gives them hope. It really gives them hope.
Medical students often ask me, is Watson going to take their job? And I have the same answer, which is for diagnosis, Watson will be a prompt, it will be sophisticated, it will expand my differential diagnosis. At the end of the day, it is the physician who's going to decide.
Doesn't make the decision for you. That's the realm of the clinician, with the clinician in combination with the patient. But bringing you the information that you would want to have anyway to make that better decision is what Watson will do for you.
A smart computer system has to come into play to serve in an assistant role.
Information available from Watson will, I hope, support my ability to develop relationships with patients, engage in complex decision-making, providing them personalized care 5 years from now, I see a transformed healthcare system.
I think 5 years from now, Watson could really, I'm not exaggerating, I believe it could be everywhere.
We'll rapidly approach a point where you won't want to visit a clinician who doesn't have access to the vast amounts of information for better diagnosis.
People are better, they're healthier, low cost, and I really believe Watson's going to be there. I see it now.
Let me just pick up on a couple of quotes from that video. Here's a doctor saying it's almost disabling to know that the answer to your patient's problem is out there, but you can't find it. There's a man who's feeling gridlocked, right? He knows the information is out there, he knows the answers are out there, and yet he can't find that information. And we know what to do about 1% of the information. Again, that overload, we can only process 1% of the information sensibly. So clearly, we need some help here. And we've been working with a number of institutes and researchers in the medical field. And let me show you, again, a short video of one of the solutions that is coming together there in the realm of cancer research.
Dr. Mark Norton, a clinical oncologist, is preparing to see a patient. He logs into the electronic medical record, and instead of spending time trying to find relevant information, he uses Watson Oncology Diagnosis and Treatment Advisor. He pushes the Ask Watson button, and Watson analyzes the patient data against tens of thousands of documents from its vast body of medical literature. Dr. Norton starts with the Case Information tab, where Watson has pulled out the relevant information, as well as suggestions for additional information to gather. Moving to the Test Options tab, he sees tests that Watson suggests that he consider ordering. He presses the Evidence button to see the reasons why Watson suggested the first test. Then he drills down further into a specific reference that supports the suggestion. Once the results of the tests come in, Dr. Norton presses the Treatment Options tab to see a panel of suggested confidence scored treatments. He also sees a list of clinical trials to consider. Again, he reviews the supporting documentation by pushing the Evidence button. Dr. Norton has new information to add to the case, so he pushes the blue Watson avatar on the bottom and speaks directly into the microphone. He makes sure that his words have been transcribed correctly and submits the new information. Watson returns a revised set of confidence scored treatment suggestions that take the new information into account. It also updates the list of clinical trials to consider. Shifting gears from Dr. Gordon's role to that of a hospital.
Let me interrupt that there. It goes into some background stuff which isn't particularly interesting. So what we've got here is this system that we built a few years ago, 2 years ago, to play Jeopardy, which is now being deployed in a range of different industries, and one of the first industries being healthcare. Well, we've got this system that can now sit alongside the clinician and advise, act as a trusted advisor. You know, I like you, I'm a techie, my background is technical, and yet I find myself talking about these type of systems with terms like thinking and learning and talking and advising. It really is hard to not anthropomorphize these systems, because they really are starting to feel like a trusted advisor, a system that sits alongside us and helps us do a better job than we've been able to do before. Let me just let me give you a brief aside here. Watson, the idea for Watson came from a gentleman called Charles Little. Charles actually ran the lab that I work in Silicon Valley for many, many years. He was in a bar in New York, and the bar was very noisy, a lot of buzz, a lot of stuff going on. And he said to somebody, you know, what's going on? Well, it was one of those Jeopardy games when one of the champions was getting one of the record take-homes, right? And Charles hadn't seen Jeopardy before, and as he watched and as he saw what was going on, he thought to himself, this could be a great application for today's computer technologies. And he took that back to IBM research, and he said, here's the challenge. You know, do you think this is something we can do over the course of the next few years? Can we build a system that will play and win Jeopardy? And of course, we did. The one concession that was made to the machine was that it didn't have to do the natural language processing in real time. It was presented the questions already in text form. But other than that, everything else was run by the machine, including deciding, you know, when to buzz in based on the level of confidence it had. So my takeaway from that little story is if the Mayans had bars, perhaps that society would collapse. Right? Don't discount bars as an important. All right, let me peel the onion a little bit here. I'd like to talk about my definition of big data and what's going on behind these systems. My definition is generally broader than the definition you'll see from other places, because I want to talk about this higher level, not just managing large volumes of data, but this higher level where we get to these really interesting applications. So a very simple definition. Big data for me is technical facilities that allow more people to analyze more data in more ways than ever before. And there are three dimensions here that we'll talk about in a little more detail. Obviously, more data. You all understand that. You're living and breathing this every day. And in pretty much every presentation I've been in today, I've heard about the data volumes that you are managing now. When I last worked in the data warehousing world, you know, a terabyte warehouse was a big deal. Now it's nothing. So you're moving the needle there every day. More people, that has a couple of aspects to it, and you just saw one of them. You know, doctors, clinicians are notorious in their dislike for technology. Anything that gets between them and the patient is seen as a bad thing. It's seen as a distraction. And yet we're getting good uptake with these technologies because we've thought hard about how do we make this technology approachable, how do we stop it getting in the way. And then finally, analyzing this information in more ways. You know, there's little value in storing and retrieving this information. There is a lot of value when we start applying analytics to this information. And there's incredible value when we can make those analytics easier to apply. So those are the three themes that I'd like to drill down on here. Those for me are the three dimensions that make up big data. So when we talk about big data, I'm sure you've heard all of these numbers before, and I'm sure you'll hear them again in the future. 90% of the world's data was created in the last 2 years. I think that came from Eric Schmidt at Google. It's an amazing number when you think about it. 80% of the world's data today is unstructured. And as you well know, because you're living and breathing it, our traditional systems are really, really good at managing and analyzing, retrieving and searching that 20% of structured data and structured information. But you step off that path even a little bit today, and things get really, really difficult. That dynamic needs to change. We know there's tremendous value in doing this. I don't need to preach to you. There are numbers down here, but you're living and breathing this. You know better than I do about the value that accrues when you deliver business intelligence and analytics. Let me talk around this chart for a moment here. So in the minute that I talk about this, 48 hours of new video will have been uploaded to YouTube, and 357 new blog posts will have gone up on WordPress, and over 3,000 new photos gone up on Flickr, 47,000 downloads from the Apple Store, 100,000 tweets on Twitter. Hopefully some of those are coming from the room right now. $250,000 spent online. Facebook users share over 500,000 pieces of content in a minute of this video. Google gets over 2 million queries and 200 million email messages will be sent. Somebody recently pointed out that probably 199,000 of those are spam, but that's neither here nor there. And the only thing I can guarantee about this chart is, again, by the time I finish speaking about it, the numbers are out of date, right? Because things are exponentiating, as Rebecca discussed this morning. I tend to talk about big data in terms of the 3, the 4 V's, right? I think Gartner originally started talking about volume, velocity, and variety, and then veracity was added, and a couple of months ago when I gave this presentation, somebody said, don't forget the value, right? So 4, 5, 6 V's. Doesn't really matter how many. There are some core principles here, and this is a nice way to characterize what we're dealing with on the data side. So this aspect of more data. I'm sure I don't need to persuade you about the data volumes. As I mentioned, when I was in data warehousing, a terabyte was a big deal. We all tend to think of the Library of Congress as being a huge repository of information, and yet it's estimated it's only 10 terabytes. I did this little calculation that said if you took all of the world's information back in 1993 and you burned it onto CDs and you gave everybody their allocation, everybody in the world would be carrying around 4 CDs. If you do the same thing in 2020, based on current estimates, we'll all be carrying around 1,000 DVDs or whatever the equivalent is. So huge growth in data volumes, and we've gone from talking about terabytes, we're now regularly talking about petabytes, and we know the next 2 levels. I don't know what comes after zettabytes. Nobody's discussing that yet, but give it 12 months, maybe 6 months, we'll be talking about those data volumes. Velocity is the second V. And what's happening here is that things are happening faster and faster. Our world is becoming very highly instrumented. I was in a talk earlier by the guys from Johnson Controls, fascinating stuff that they're doing, and they talked about the instrumentation just on a room like this. And then when you think about all of the buildings in the world, and then you blow that up to all of the sensors that are out there in the world, you've got massive volumes of information that are flowing. If you think back to the 90s, we started coining these acronyms for the way systems interact, and we came up with B2C for business to consumer and B2B for business to business. The latest acronym, the one that we're starting to talk about now, is M2M. It's machine to machine. So those sensors are now getting smart enough that they're starting to talk to each other. And in fact, the Johnson's folks were talking about their sensors already rolling up information to back-end systems in their offices, which they can then take action on. The day is not far away where those sensors talk to each other and then make some intelligent decisions and then talk to the service rep directly instead of having to go through that central server. I worked on a project with some technologies based on shipping containers. So this is probably one of my best contributions to mankind to date. We got good beer from Europe into the USA and to consumers faster than ever before. And that wasn't about shipping technologies or improved logistics. It was about the information. It was about having sensors on the container, so the port authority didn't have to open the containers up, didn't have to slow them down, but based on the sensor information that they got from the container through its whole journey, they knew exactly what was in it, they knew it hadn't been opened, and they knew they could just flag it straight through the port and out into the systems. So tremendous acceleration happening because of the degree of intelligence that's being pushed down into the world, and that's just going to continue to increase the velocity. And then variety. You're all dealing with structured information. When you start looking at text and video, audio, images, logs, and social media, things get even more interesting. I think, for this audience in particular, probably the first stop is going to be, it's going to be logs. All of the interactions that are happening with the systems that we're working are generating log files. There's this digital exhaust, as we talk about it, that's flowing out into the world behind the systems that we're working every day. And businesses are starting to make sense of that exhaust. There's value in that exhaust. Let me give you an example. A few months ago, I got my cable TV bill, and it had gone up, and I didn't understand why the increase. So I went to the website, and I poked around on the website to try and find out what was going on. Couldn't work it out. I left. 3 or 4 days later, I got a call from the cable provider saying, we noticed you were on the website. We noticed you didn't order anything or change anything. Can we help you? And so I said, well, my bill went up, and I didn't understand why. So I was looking, and they explained that it was a general price increase, and I should have read this on my previous bill. And by the way, it was a $5 increase, but given the fact that you weren't happy about it and you actually took some action, we're going to give you a $10 discount for every month for the next 6 months. Yeah? So they spotted. What they didn't know was I had actually left the website thinking, I got a flyer from another provider recently. Maybe this is the point at which I go look at that other provider. So they kept me for another 6 months. And of course, with the discount, I'm a happier customer, and I'm still there. I don't know how long this was ago, but it was sometime last year, I think. So that little bit of research, that little bit of analysis based on those log files, helped them keep a customer, which, as you all know, is a good thing, because customer retention is far more cost effective than losing it and then trying to win it back. The veracity of this information, of course, is absolutely critical, and you live and breathe this every day. If we can't trust this information, if we can't govern this information, if we can't secure this information, then all is for naught. And we've had some really great examples of the cost of not securing our systems, whether they be big data systems or traditional systems. The damage done to the large retailers recently, all of the noise we're hearing about the NSA and so on. This is not going to go away. So we need to be able to manage and govern and understand these systems, as you would expect. So don't lose sight of that. Just because it's new technology and it's all big data and it's all very exciting, all of those fundamentals, the stuff that you've learned over the years the hard way, it's still applying. So that's our more data dimension. The next dimension I'd like to talk about of our definition is more people. So we need to give people more access to this information. And for me, there are 2 elements to this. One is the economics, right? The economics have changed. That's part of what's making these big data systems viable. We've moved the level of processing that we're able to do now out of the realm of supercomputers and into the mainstream. And that really is happening. We have one application in particular where a supercomputer has been unplugged and a Hadoop cluster has been plugged in to drive business decisions. So there's an economic element, and we'll talk about that a little more. And then there's the access element, and again, you all see this with the user interfaces that you're building. You know the interface can make or break an application, and we have the same thing with these systems. And I think that's where Watson gets particularly interesting. A Watson system that told you the answer to life, the universe, and everything was 42 would not be terribly interesting. But a Watson system that says, I have a 95% confidence interval that the answer to life, the universe, and everything is 42, and you can say why, that's a system that's got a lot of utility. So that's the kind of change we're seeing here in terms of access. So let's talk about the economics. First of all, there's a hardware side to this, right? We're taking these commodity systems, we're taking these systems on a plane, and this system here that you're looking at has 2 CPUs, a whole bunch of memory, a whole bunch of storage. And we rack those up into carriers, and then we rack the carriers up into large racks, and we network that whole thing. I was at a conference recently where another speaker was talking about the human brain and the fact that the human brain is a networked system. And as I listened to him speak, you know, I started to think about these systems, which really are highly networked, highly interconnected systems of commodity hardware. So we're getting supercomputer level storage capabilities at commodity prices. You can get into this game for, you know, the price of a family car. This is not something that's the realm of the specialists anymore. Watson, an entry-level Watson system, is running somewhere around the price of an MRI system. So it's now viable for hospital to make funding decisions that say, you know, do we fund that new MRI system, or do we fund that Watson system, or do we fund both? Those are now viable decisions. Not so very long ago that was impossible. And of course, open source software is making a huge difference here, and the cloud is making a huge difference here. So being able to build off that open source stack has great economic implications for you, because you're getting tremendously sophisticated software at lower prices. But it's also driving an interesting dynamic in the market, in that, you know, there is little point in IBM, Cloudera, and Hortonworks, and MapR saying we have a Hadoop distribution. At that level, everybody's got a Hadoop distribution. So we're all driving up the stack. We're all driving to add more value beyond that basic stack, whether that be additional software, additional analytics, additional capabilities. You can see that the industry is being driven as a result of the open source software stack that's behind this. Interesting that this whole system is architected to cope with high failure rates, right? One of the things that's fundamental here is that you rack up all these systems and you use commodity hardware, knowing full well that it's going to fail. In large deployments, large clusters, many racks, it's routine for systems to fail. The software keeps running, and then the administrators can go around and unplug the failing components, plug in new boards, and the system keeps running. So an interesting model, an interesting parallel with some of the things Rebecca was talking about. I mentioned the open source software stack, and when you think about it, there's tremendous value here. When you look at what you're getting in terms of being able to process the volume, the velocity, and the variety here out of this open source foundation, it's tremendous. And it's very sophisticated software as well. So the industry is moving at pace here, and a lot of sophisticated software coming out of this initiative. The pace it's moving, again, is quite staggering. Interesting to note that it in itself it's a complex environment, right? This is not Mickey Mouse stuff. Okay, so in addition to the economics, which say we can now put a very sophisticated system in a hospital for the same price as an MRI, or you can start processing that digital exhaust for the price of a family car, we also need to make it easier for people to leverage that information and make sense of that information. And Watson, for us, is at the core of this. One of the clinicians in the video I showed you earlier has this other quote. She said, just the way we do a Google, we're going to be able to do a Watson. And that's indicative of the way things are changing here. She's thinking in terms of engaging with this very sophisticated software in a very natural way. And the idea that Watson works with the physician inside the electronic health record or the medical record as they are doing their job, and the type of interactions that you saw there, the type of dialogue that's going on there is a tremendous change and fundamental to where we're going. So the idea that you can push a button here inside the medical record and say, ask Watson. You know, what does Watson make of this information? What are the analytics that are being applied here? What can Watson tell me about this patient? It's like getting a second opinion, right? It's getting a second opinion from a very, very highly informed source, a source that's capable of digesting all of that information in a fraction of the time it takes humans to digest it. And we can ask Watson, on what basis are you making these recommendations? What's the evidence? Show me why you're making this recommendation. You can guide that. You can influence that. If a recommendation is being made based on a particular study that you have low confidence in, you can indicate that. You can tell Watson discount this, and Watson will do that. And if that happens regularly, Watson's going to learn from that and understand that there's not much credence in this particular set of information, and therefore lower its priority. And then the idea that we can look at the level of confidence of the recommendations that are being made here and see, you know, is there a clear recommendation here? Is this very clear? Or is there some ambiguity? How should I think about this? And there was also, in one of the earlier screenshots, there was an area where Watson was recommending tests. So based on the analysis that's been done here, Watson is capable of reasoning about additional information that would help raise the confidence levels, and then recommending to the physician, these are the tests that would help make this decision. I gave this presentation last week, and one of the audience members was a doctor who is very down on Western medicine and very excited about alternate medicine. And, you know, he came to give me a hard time about, he said, you know, you're perpetuating the bad things about Western medicine. But the fact is, this is not, at its heart, a medical system. If we fed the system information about alternate medicine, then it would be an advisor for him in just the same way as it's an advisor for more traditional Western medicine in this scenario. So we can repurpose this technology, and that's already happening. And we can add new information here. A lot of people say, well, if you could marry Watson with Siri, wouldn't that be something? Well, of course, it's already happening. You know, you can already talk to Watson, and it will listen. Okay, so that gives us more access. So we've done more data. We've done more access. Our third dimension here is more ways to look at this data, or more analytics. So a word about the way these systems are operating on this information. It's different, right? The systems that we're dealing with yesterday, the systems that are still deployed today, they're very deterministic applications. When we talk about these systems, we talk about the algorithm, right? The algorithm is absolutely fundamental here. Rebecca mentioned the failure of artificial intelligence. What we tried to do back then was, you know, take the information, the knowledge, the processes out of the heads of the experts and encode algorithms that went through that same process, and that failed. So these are not deterministic applications. If you look at the applications to date, they're very search-oriented. Look at your business intelligence applications, right? Many of them are about retrieving and presenting information, albeit aggregated, albeit with analytics applied, albeit with additional intelligence. It's essentially a search and retrieve problem. And of course, you know, the classic application here is Google. And the access is machine language. Everybody in this room knows what SQL is, right? And it's a machine language. It's a machine language that we're also familiar with. We kind of think of it as our own, but it's a machine language. And if you think back to Google and Yahoo in the early days, you kind of had to talk to them if you wanted to guide the search with, you know, some cryptic stuff going on, machine language. They've gotten a lot better. The fundamental orientation was search with machine language driving the search. Incidentally, the picture here is an IBM System 360. Way back when we bet the business on System 360, and personally, I think what we're seeing with Watson is as fundamental as the shift that we went through with System 360, and I think it's going to have that much of an impact. So today's applications, not deterministic, they're probabilistic, and you've seen examples here with Watson. In fact, when Watson was playing Jeopardy, right, it would show the potential answers that it had found with confidence levels. So there's a probabilistic approach rather than a deterministic approach that's coming to the fore here. The orientation is discovery. So we are feeding Watson information. It's combing through that information. It's applying analytics, and it's extracting or discovering linkages and cause and effect and correlations within that information. And the access is natural language. So we're speaking to Watson, and Watson is now capable of having a dialogue with us. So a very different model behind the application of the analytics. And here's this process spelled out in the case of the Jeopardy playing machine. So Watson understands the natural language questions. As I mentioned, the one thing that it didn't do was do the speech to text, but everything else went on in real time. And then we analyze those large volumes of unstructured data. So one of the major sources of information for the Jeopardy playing system was Wikipedia, right? For all its good and bad, that in unstructured textual information was a large part of the knowledge base that Watson operated over. And in the medical world, obviously, it's physicians' notes and so on. And then the system generates and evaluates various hypotheses and presents responses with confidence intervals, as we've seen. And then we have this dialogue. We have this idea of being able to refine, of being able to ask why, of being able to suggest that some things move around, of being able to get additional information and see what that does to the diagnosis here, or does to the answer that we're being given. And then the system continues to learn, right? So this is not a program it once and walk away. This is an information discovery and an ongoing process. So as that new information, that doubling of healthcare information continues, Watson is able to continue taking that information in and learning, as well as learning from the people who are interacting with it and their preferred way of working with the system and in the domain that they're working in. There are many analytic techniques that we can apply here, and these are all going to look very familiar to you because we've had these for many years, right? I used to make my living in multidimensional analysis technologies. I've spent time more recently in text analysis technologies. You know, in those situations, I'm the expert. I'm the guy who applies the analytics and applies the analytics in the right way, and I'm the bottleneck, right? Can't afford to have me in the way. You need to get me and people like me out of the way so that the clinicians can drive the analytics, albeit indirectly. What we really want is the machine driving the analytics. You know, statistical packages, for the longest time, one of the first IBM systems I was associated with had a stats package. And, you know, I scratched my head and I said, you've got to be a statistician to even begin to make sense of this, to know how to apply the right tests and interpret the results. And that makes no sense to me. You know, why employ a statistician to drive a statistics package? Well, we're now getting to the point where perhaps we can take some of that expertise and encode it in our systems and have the analytics applied automatically. I need to start with. Okay, some examples. Complex systems in the world today where big data is already being applied and making a difference. Systems in transportation. This particular system is improving the way public transport is handled around Dublin. But there are other examples out there where traffic systems, city traffic flows, peak traffic flows are all being managed. I'm from the UK. There's a system of motorways that go through the middle of England, which for as long as I've been around have been constantly congested. They're at a standstill 7x24. Those systems are now managed motorways, so they dynamically regulate the traffic flows. I don't know whose systems they are, but they're absolutely amazing. They're a work of technological and engineering brilliance, and the traffic now flows much better than it ever has before. In the world of oil exploration, a lot going on there, both with the management of the rigs, with the instrumentation, the types of sensors that I was talking about earlier, but also in managing the environment. If you place these systems in the wrong place, if you place a rig in the wrong place and things get iced up, bad things happen, and a lot of money is wasted. So getting these rigs in the right places, in the right environment, and then managing that environment to make sure that ice doesn't build up around these systems. Huge volumes of money, and a lot of money being saved as a result of big data analytics in this environment. This is the system I mentioned earlier where this particular company builds wind turbines. They had a supercomputer aiming to help them understand where to place the turbines. This is not just about placing the turbines where you get the best wind flow. This is about placing them where you get good wind flow, but you don't overload the turbines and cause maintenance problems. University of Maryland doing work on fire and smoke systems and how fire and smoke spread and disperse and how to best fight wildfire. So a lot of work in the environment with complex systems in the environment. This system in Galway Bay is interesting because it was originally put in to help understand water movement and flood levels and potential floods from Galway Bay, but they found that they hung audio sensors off the buoys. They could also learn a lot about the wildlife in Galway Bay. So marine wildlife advantages as well. There are lots of other projects in lots of other domains. Big data is going mainstream really, really fast. Let me spend a couple of minutes here on a project that affected us all, a big data project that affected us all. This is a dashboard. This is a dream catcher. Anybody know what this is?
Narwhal.
Very good, it's a narwhal. These three projects were part of the big data organization that President Obama put together to get himself re-elected in 2012. And they have a huge department running this. More importantly, they got the political pundits to agree that they would put aside their gut feel and listen to the evidence and work with the big data. They had a lot of data from polling data, they had a lot of set-top box data, and they were able to match those together and carefully match people who were calling, voters, and the voters to get much, much better results. You all know the results here, right? I was due to fly the day of the election, or the day after, And so I decided I would go to a movie, go to dinner, and then basically stay up all night and watch for the result. By the time I got out of the movie, it was all over, right? And yet we were being told it was very, very tight. So a tremendous difference in the result, and a lot of it down to big data. One more story, and then I will stop. I'm being told I'm out of time. So prior to the actual election, the campaign ran a fundraiser on the West Coast, and they had a dinner, and they brought in George Clooney, and they made a lot of money. So then they asked themselves, so what should we do on the East Coast? And they ran analytics, and they polled, and they looked at demographics, and they decided Sarah Jessica Parker was the right answer. And then, not content with having simply identified the right person, they then crafted 7 different invitations, 7 different email invitations, and they carefully matched who you are and your demographics with one of these invitations. So tremendous, tremendous application of big data that got the president-elect. I don't have time to show you the data baby. Let me talk about it for just 2 seconds. Typically, babies that are born early, they go into the neonatal intensive care unit, and they're hooked up to monitors, and thousands of readings stream off these babies to these monitors. You've all seen these. And thresholds are set, and alarms and alerts fly off these when things go out of bounds. The work that was done here with the Children's Hospital in Canada and the University of Ontario found that there are particular viruses where the sign that something is going wrong is not something going out of bounds, but it's actually some of those vital signs settling down and losing some of the extremes. So heart rate and respiration and pulse ox and so on have a very natural 24-hour cycle, and that cycle was flattening out. Very, very hard for the doctors and the nurses to see. Very, very easy for streaming big data technology to spot across many, many babies and raise an alarm and alert that things are looking too flat, and that perhaps one of these viruses is setting in. If you can spot those warning signs 24 hours earlier in a baby that's literally only 2 or 3 days old, then you are saving lives. So big data today is already at work saving lives up in Canada and will be deployed elsewhere. So thank you very much for your time and attention, and I look forward to being back here in the future and hearing about all your applications of big data, because the stuff I've heard today has been absolutely tremendous. Thank you.